Okay, well, thank you very much. I certainly appreciate your time coming out on this pretty warm evening and fighting the heat and everything. And so, what I'm going to talk about with you is, what Stuart was mentioning there. We're going to talk about fish. And I worked for about 20 years in the Pacific Northwest before coming down here in 2000. And everybody was making fun of me when I came down here, and they said, Scott, what are you doing going down to that desert? That's crazy. What are you going? There's no fish down there, you know? And so I got down here, I saw this, I said, well, maybe they were right. But I spent more time here. And the more time I spent here, the more I realized this place is wonderful for a fish biologist. It's a hidden secret. And so tonight, I'm going to talk with you about a little bit about some of the fish that are out there, but primarily I'm going to talk with you about some of the work that goes on, about people managing fish, why it's important to you folks, why these native fish are important and non-native to y'all, and then some of the research that's going on at the University of Arizona about fisheries. So here's what I saw. When I came down here, I saw that sand at first, but then you guys have big roaring canyons with incredible rivers at the bottom of them. There's these wonderful streams and mid-elevation rivers that are loaded with fish. Here's some of my students out sampling on the Verde River. There are these springs that are middle of the desert that are separated from other water sources by tens of miles. And so you can have a little universe just in that one spring of aquatic creatures. You have some of the most southern trouts in the United States here in the mountains of Arizona. It's just a 3-hour drive to some extremely interesting trout species. So they have this whole group of fishes, but let's face it, if you're an aquatic creature, living in the desert's tough. You've got things like this, it's not just the lack of water, but you've got when water comes, it comes fast. And you have these huge flash floods that come down. I remember the first year I was here, this is the CDO wash, just right behind our house. And somebody tried to cross. I saw these signs that would say, oh, flood, don't watch out for the floods. That's crazy. But then the first one hits, and then somebody tried to cross, and we had this going on. Okay. And so if you're a fish down here, you have a series of things that you have to do to live in this environment. Some of the fishes that live in the Grand Canyon, they have like that razorback sucker up there. They have kind of a keel. It's like on a sailboat. It's on the top, holds it into the current, with these big roaring rivers. You don't have to have big eyes because the water is so cloudy out there and turbid. You have to have powerful muscles and tails like the humpback chub down there with big humps on the top. That's the big 6-foot minnow, the Colorado pike minnow. And those things used to be throughout the Colorado River Basin, huge predators down here. We have very interesting things called pupfish that live in the little springs that are around in the desert. And then everything in between. And I mentioned previously the trout. We have the Gila and the Apache trout, extremely unique species. And when we say the rarest fish in the world, there's not, some of these species are located outside the state or outside the Southwest, but a lot of them have a very small distribution. So they're rare. It's like having rare jewels around to enjoy, okay? Right here, this is a spring over in California. The world's entire population of Mojave tui chub used to live in that spring. And so when I came down from Washington State, it was from, you're sitting there going, oh, wow, salmon and large river basins and everything like that. And then you're looking something like that and you're managing it. And really, this kind of management is like being a terrestrial biologist and managing animal populations or terrestrial animal populations on South Sea Islands. They have their own species on a lot of these South Sea Islands. You think Galapagos tortoises. You think things like the dodo bird, okay? All these things are sprinkled around on these islands and they have to be managed. Well, that's what we do in the desert. We're managing aquatic islands, And so the thing is just like these terrestrial animals on the South Sea Islands, we've got these animals are endangered, a lot of them, because there's not a lot of them. So the same sort of problems that you would have in the South Sea Islands, you have here, okay? Well, how are the fish in the West, in arid lands doing? This is a little dated, okay? But there's a guy called Lee, and he put together this whole compilation of the fish species and subspecies. 150 full species are included in the fish fauna of the West, okay? Now, 122 taxa west of the Rocky Mountains have either disappeared, they're threatened, or they're endangered. That doesn't leave a whole lot left, right? So ours is a job of managing scarcity. A lot of times it's managing something that we want to hang on for future generations, but that is kind of the place we're in. So modern fisheries techniques management, you do things like you manage interactions between native fishes and non-natives. We're going to cover that here in a little bit. Stocking still used, but it's not used as much as it used to be, and I'll talk a little bit about that. And then habitat improvements, also very important for managing these fishes. But before we manage the fish, we got to figure out, what good are they? I mean, that's what people ask. Who cares, right? I remember getting called into the dean's office one time, and the dean goes, I say, how unique and neat these are. He goes, Scott, give me something I can use with the legislator. You know, that's, you know, a fish there's some reason, okay? I mean, I could just look at this is Clear Creek. Those are desert sucker, and you can snorkel in and see these things just like you would you know, on a reef or something like that. It's amazing, but we got to have some more. Okay, so what good are these fish? Well, first off, they're important components of healthy southwestern aquatic ecosystems. All the other animals, terrestrial animals, insects, what have you, the bird populations, they've evolved with these fish. Okay, as food, maybe as competitors, maybe as predators if they live in the water. And so they're important components of healthy southwestern ecosystems. Now, if you take one out and it disappears, will that crash the ecosystem? Somebody told me one time it's kind of like predicting what would happen if you take a rivet out of a plane. If you take a rivet out of where just the seat's being held in, or the ashtray, no big deal. You take the rivet that's holding on the engine, that might be a big deal. And the thing is, we don't know, you know, ahead of time. So why take the chance, right? Also, this was fascinating, some of the reading that you can find out about these native desert freshwater fishes and other aquatic species. They've proven useful for humans for centuries. We have thousands of years of evidence that desert fish have provided for people. Sport fishing. The first sport fishing was on desert fish in Egypt, believe it or not. The first metal fish hooks were developed in Egypt, again, for sport fishing these desert species that were in the Nile River. The fish was considered a god in Egypt. You can go to the British Museum and see fish mummies. You know, the Jesus, you hear about the loaves and fishes and the biblical thing. That was a tilapia that those people had, and it was a fish that lived in the desert, in the Sea of Galilee and whatnot. That was very important in the Christian background. There are things like the electric catfish that you can find in the Nile River. Now we talk about Ben Franklin finding it through electricity through the kite. The Egyptians and some of the people who are living in the desert in North Africa were finding out about electricity a lot sooner than that and getting zapped if they pulled in the wrong fish. Also, today, these animals are very important and people are using them for. The pupfish species, if you can imagine, they're living out in these salt line ponds out in these hugely very hot temperatures. You've got to have some pretty good kidneys that will take care of you in that situation. And you have to have other factors that allow you to live in very harsh environments. And so we study those for medicine. I mean, people are looking at that. What kidney function, some of the other biological functions, osmosis, how does that all work biologically in these animals. And as we know, like with the Pacific yew or some other trees that have, and other plants and other animals have been considered worthless until all of a sudden they find out there's a medicine or something can be developed on them. There are diving beetles. You may have been out to a park and seen these brightly colored beetles. Maybe it's Sabino Canyon, maybe up at the Romero Pools up in Catalina. Those brightly covered beetles, they were used to develop video technology. And so if you can look at their eyes are shaped in a certain way and are split up, that videographers looked at that and used that to improve their videography design. This is not a fish, but the sacred datura and a lot of plants, they have to deal with the heat too. And one way, small leaves, but the other way is having leaves tilted at certain angles or having them, the microstructure made up in certain ways. And architects look at that. Clothes designers look at that. All of that is being used to design and help people, okay? But let's face it, some of them really don't have a whole lot of use. And so this beetle, this titlet beetle right here, this has a genetic code that is printed in regular letters, would go from coast to coast. I mean, just huge biological masterpieces, genetic masterpieces. And we think about, well, we don't use that thing. We don't see it every day, right? No. Think about the great works of art. Do you go to the Louvre every day and see it? Do you use it every day? No, but you just like knowing it's there. And would you allow people to bulldoze the Louvre for a parking lot? You'd use it more, you know, but it sounds crazy, right? Well, in this kind of situation, one might think that these biological specimens are genetic masterpieces of themselves, okay? But let's talk about this, money. Money is a big driver on whether we protect this or protect that. What is the economic value of these animals? Well, stick with me here. So in 2011, 18.3 billion was directly spent on tourism in Arizona. Can you tell me the greatest two tourist spots? One's private, one's public. Grand Canyon's one. There's another one. What's that? Nope. It's a private, yeah. Yeah, it was a private, it was a category, private places.
Golf courses.
Well, not quite.
Resorts.
Tempe Town Lake. That received more visitors than, you know, the top private attraction for that year. And so what do these have in common? They both have water. People love their water. And so the thing is, it doesn't just stop there. If you give people a chance, they like to see desert fish. Now, there is a wildlife refuge. It's called Ash Meadows National Wildlife Refuge. Has the highest degree of endemism. That means species that are found only in one place of just about any similar sized area in North America. If you want to see lots of species, I think it's 23, 25, I can't remember offhand. You go there. They're found nowhere else in the world. That's the place, okay? And so this place gets 67,000 visitors a year. That's an old figure. That's gone up substantially since then. Okay, that National Wildlife Refuge receives more visitors per year than 106 national parks and monuments. So you got all these people coming in. North Cascades, the Chiricahuas. There's more people going there than the Chiricahuas. And what does that mean? Well, they generate money to the local economy. And I'll just tell you a couple of words in a nutshell. What this is the Park Service did a deal where they found out that people were spending about $50 a day in the local communities when they were visiting that area. And so we calculated 67,050 people, or $50 a day. That's about 3.3 million that these small, tiny little fish are bringing into that local economy. And if you turn that into, here's what an average person makes in that area for a job, that's 121 jobs per year in the local community. So somebody will come up to you and go, why are you worried about those fish? And you go, well, it's helping you make some money. I would turn these fish into a festival and try to get more people down here, you know, for that. So it's a good deal on that. Now, Sabino Canyon, think about it, 67,000 visitors. Sabino Canyon gets 1.3 million visitors a year, okay? And I would argue that, you see, my favorite part of Sabino Canyon is going underwater, okay? Because you can do it with a mask and a snorkel. It's really easy. Nobody knows about it. But here's what, we made a movie for the front, and I'll just play just a little bit of it. And we have some waltz music usually with this, and it goes along and it tells people what the fish are down there. This is just snorkeling. You know, so you're going down there, and that's what it looks like underwater. Nice clear water, and nobody knows about this. You know, you can see all these, and these fish are found nowhere else except for this one small area, you know.
Does is there year-round water in portions of Sabino?
Yeah, in portions. You're right, it dries up a lot. And the fish either make it or they don't, some areas. Okay. So these fish are pretty special. So what factors threaten the fish, and what are we doing about it? Well, first off, non-native species. How many of you like to angle? Like to go out? Any of you are fisher people? Okay.
Well, 7.
Okay, well, I'm about the same. Okay. Well, the species that people fish for in Arizona, except for those two trouts primarily, are non-native species. And you might go, well, where'd all the bass and all these things come from? Well, the first one that came out here was the carp. And after the Civil War, people thought, carp, that's going to be like the next hog in the backyard. We'll have a little pond, we'll put some carp out there, we're going to eat the things. So they are not from the US, they're from Europe, and people would love them. They love to eat them in Europe. So people here thought that might be a good idea. In fact, so Spencer Fullerton Baird of the Smithsonian Institution, he was getting going on this. And in the 1870s, the carp came in earlier. They put them in ponds around the Hudson River. If you killed a carp back then, you were fined $600. No, I'm sorry, $50. And $50, and the salary, the average salary of like a Civil War lieutenant back then was about $600. So you think about what percentage of that salary, it's huge for killing a carp. Fast forward to the 1870s, Spencer Fullerton Baird, people are going out in the Homestead Act. They're going west, right? And it's arid out here. It's tough to make a go of it with cattle. Let's have a nice little pond in the back, and we can get water in it. Once we got water in it, we're okay, and put some carp in there. And so people out here loved it. You can go to the old archives and you can find, you know, one of the first Arizona fish commissioner was a roommate of Doc Holliday's. You know, they have all these kinds of things going on with them trying to get carp into Arizona. And so Spencer Fullerton Baird, the first carp ponds in the US were at the bottom of the Washington Monument. They dug them there and they raised carp, okay? And here you see a wagon that's coming to a railroad that's filled with buckets of carp for stocking out in the West. And so they developed special trains to carry all these animals. And it wasn't just carp, it was bass, it was sunfish, you name it. And they said, let's give it a try. That was a way of thinking back in those days. And these were modern marvels. These cars are contemporary marvels. These things had ways to keep the fish cool, ice, areas for ice, areas to bubble, keep the fish alive and everything like that. And there was one hatchery worker who loved his job so much, and it brings a tear to my eye each time I think about it. But he took his wife on his honeymoon, on their honeymoon, on one of these fish cars. I mean, that's loving your job, isn't it? How'd you feel about that? I don't know how long the marriage lasted. Okay, and so when people say, hey, the government is not very effective, I say BS on that, because what happened from 1903 to 23, over 72 billion fish were distributed by fish cars and detached messengers traveling over 10 million miles. I have this thing at the bottom that turned on. Did I do something wrong there?
It was whenever that pop-up came up that you accepted, apparently moving on. So just let it keep going, I guess.
Okay.
We just have captions now. That's okay.
Okay. Okay. During a 1-2 month period, fish were sent to virtually every state in the union, and cars were kept busy day and night stocking. Talk about large animal migrations. This has to rank up there with one of the largest in history. Moving fish from the east, from Europe, and getting them into the west. One of my students did some work with the EPA to try to find out, well, what's the distribution of fish right now? And over 60% of the stream kilometers in the western United States have non-native fish in them. So they did their job. They got them spread. So is this a problem? Well, the non-native fish, a lot of them are from areas that have a big fish community, and the toughest guy or gal on the block makes it. Okay, so you bring those fish and you bring them out here. Desert fish communities are what they call depauperate. There's not a lot of species. And so what happens is you get somebody in that's used to beating up on other fish. Well, that other fish is going to eat you probably, or outcompete you. And that's what we saw. And non-native fishes have been cited in over 63% of cases of native fish extinctions. This is a little bit older, and non-natives have been cited in 49% of Endangered Species Act listings. So they're having quite an impact. But angling for non-native species is very, very important to the Arizona economy. You wouldn't think it would be, but go down there and look at expenditures on Arizona fishing only. Can you see that? Almost $1 billion. Okay, and it is over $1 billion now. $1 billion a year. That's people buying fishing licenses, boat gas, hotels, rods and reels, all that kind of stuff. Okay, so look down there for spring training. Everybody talks about baseball spring training. That's only a measly 310 million at that time. Okay, so the fishing, the fish and wildlife watching, the fishing, hunting, and wildlife watching. Look how they compare to those figures on there. It's a big deal. So that is the non-native fishes, and that's something we have to manage. And the non-native fishes are just fine in some water bodies where there's not a whole lot of competition, or there's not a lot of escape and causing problems. But in other places, they do have quite the significant impact. Other things that affect them are changes in habitat. Okay, so you've probably heard this figure: 0.4% of Arizona's total area consists of riparian. Those are aquatic habitats. Okay, but 80% of the vertebrates in Arizona, and some people say even higher, 90%, spend some portion of their life cycle in these aquatic riparian areas. I'm talking mammals too. You know, they got to come down to the water and drink. You know, they may set up a place where they live in the woods next to a river. So these are extremely important for all Arizona species. Well, as we know, the more people we get down here, the more water we need. And so here's a map of wells and Tucson well fields. And the water, I think in the old days, what was it, like a 30-foot depth? And now, as far as digging a well back maybe 100, 200 years ago, and now it's, somebody help me out. I know you guys are working on water, something like 800 feet. So it's down there. Is it something like that? Okay.
It's about 120 in the middle part down.
Okay. Okay. So it varies. It varies then.
Hydrogeology.
Okay. Okay.
They would even go back east of Florida to that piece hydrogeology.
Oh, yeah. Then you're fine. Then you're fine. Yeah.
So
Mhm.
down.
Yeah, it's something. Well, also, it's not just people getting drinking water, cattle, crops, anything like that. Mining takes a lot. You got to have a lot of water for the process of getting the ore taken care of. Okay, and riparian areas are disappearing at an alarming rate. They have disappeared. Here you see the stream flow. This is the mean stream flow, average stream flow for June, measured from 1904 to 2002, and that's on the San Pedro River. You can see that just going right down. Okay, when you go up north, here's what I wanted to see, strangely enough. I had always heard about this place, but I wanted to find it. So I was able to go out in there and hike and find the thing. But if you go up around Picacho Peak, across the highway from Picacho Peak, there are all these cracks. I mean, big cracks. They'll look like washes, but they're not quite. That's the land that has subsided when they've pumped the water out from under it. Okay, so it can be a pretty big deal. We'll talk about climate change in a little, so I'm going to hold that right now. Okay. So what can the fish biologists do to take care of these aquatic environments and these fish? Well, here are the fisheries management techniques that work mainly down here. Management interaction among native and non-natives. Stocking still used, but not seen as a cure-all as it was previously. Habitat improvement is also important. Let's go through these. Non-native species. How we typically manage non-native species is you build a barrier, you get all the native fish out above that barrier if it's a mixed community with non-native fishes. You try to get as many as you can. And then you go in and you use some sort of piscicide is what they call it. It's a fish. It kills the fish. It's a chemical that kills the fish. Most of our chemicals that kill the fish, they're made out of rotenone. It's the roots of a tree in South America. And in fact, there were, I think there's over 150 plants that have rotenoids in them. And the Seri Indians, you know, the old man cactus that has the fur kind of on the top. Well, they used to chop that up. It has some of these chemicals in, throw it in the Sea of Cortez, and the fish would come up, you know. And so they used it as something to catch fish. Well, anyway, this is one of the chemicals they use, but you know, chemicals, not everybody wants them around there, no matter what their effect might be. And so they also use mechanical control techniques. These, you have to put a lot of effort in because fish are wily. They get away from you. And you put a lot of effort in and they're moderately successful, but you've got to really, really put a lot of effort in. Well, recently they started developing genetic techniques. This is my student, Chad Teal. He's now a professor up in Utah. And he worked with some people in our lab work on developing these fishes. See, fish, their sex determination is not really set that hard, not like people, okay? So you can have like maybe a whole school of parrotfish. And if the head, I forget it's the head male or head female, one of them dies, then another one changes sex to take its place. That's the kind of flexibility you'll have. And all these fish are different. Some will have like us, there'll be XX, XY chromosomes. Some are the female is the heterozygous. So it'll be like a ZW, ZZ chromosomes. Some, it's just the environmental characteristics that determine their sex. So it's a weird mishmash. But for some fish, Chad here, what he did was he used hormones and a combination of types of breeding. And you can get at the very end of it, if it's a XXXY, you can develop a fish that's a male that has two sets of Y chromosomes. Okay, it has Y chromosomes. So think about that a little bit here. Okay. So right there at the very end, you've got a YY that spawns with an XX. Everybody is going to be an XY. Okay, everybody's going to be a male. So what that does is that you can gradually get rid of a population of fish that's you know, one of these introduced populations that are nuisance fish. And so he tested it. He did the first red shiners. He worked on green sunfish. These are both pests that go in and crowd out our native fishes. And so he did that. Okay. So managing habitat for desert fishes. The courts. That's one of the things that we have to use. And we supply data to the biologists and the managers so they can use that data not only to manage the habitat that they have control over, but to protect stream flow, to protect habitat out there. So if the managers know what they need to do, then they can decide what they want to do. Is it worth protecting? Is it not worth protecting? Do we need more flow? Is it that we have enough flow? Okay. So this comes from, they have a thing called the Federal Reserve's Water Right Doctrine. And what it says is, if you can't take the water and it'll affect the water on a quote unquote federal reservation. It started out with tribal reservations, but later it got to national parks and everything else, you know. You can't take the water out of it and have it affect the primary purpose of the reservation. And you can let people take it out until it meets the minimal needs of the reservation, the minimal needs. So what's the minimal needs? You know, so that's where the biologist comes in. In a stretch of river, you got to be able to show what's the minimum amount of water the fish need. So the onus on proof is on the biologist in a lot of these situations. So what we do is we put a couple of rods in the water, and we put electricity to it from a generator. The generator stuns the fish momentarily, right where those rods are. See them? And then all the fish come up, and then that's Norman Mercado Silva. He's a Mexican biologist, is working with me. He'd scoop all the fish out, and then we go measure the habitat that was over. Is it a pool, riffle, run? You know, what is it? And then from that, you can develop, we worked with modelers up in Fort Collins, Colorado, and you can develop maps of proper fish habitat. So the red is speckled dace, the blue is green sunfish. And so what happens when we take the water down? That's the amount of habitat each fish has. Okay, so there we go down to here. It's pools. This introduced sunfish is just fine in the pools. And the people would argue, hey, we left you some water. You got some pools out there. But now we can argue, no, you got enough water for that exotic fish, that non-native, but you don't have it for the natives. And that's the kind of things that we're able to do. But outside of base flow, that's the flow at the very base. There's the whole, you know, we were talking about the floods and everything earlier and what these desert fish had to evolve in. The entire part of the hydrograph is important for these fish. And floods are very important. So we're out here camping. Here's this place on Cherry Creek. We're way out in the wilderness, pitched our tent, woke up the next morning, here we got this. So we were stuck on that shelf for 2 days. We had satellite phone, you know, we were okay, and we had plenty of food, but it was amazing how fast that hit. But the thing is, you don't want to get rid of these floods, because right after these floods is typically when you see a big production of the young native desert fish. I don't know, the fish moms or whatever, it triggers something, or there's places that work for them, habitat or something like that. But you usually see a big pulse of these after a flood. So floods are important on maintaining them. Okay, and so I just wanted to acknowledge my students who are doing all the hard work. Okay. So we've been at court, you know, a few times as expert witnesses. And what we do there is we just say, here's what the fish need. Here's what we're seeing scientifically. You guys can decide if that's good or bad, but here's what we see. So we've done it for Aravaipa Canyon. Here's one we did for Cherry Creek. And sometimes it works out. Here's a Freeport Macmoran that got a hold of the Forest Service and said, we've decided not to pursue our objection to your in-stream flow, what you're asking for. So every once in a while you get one, right? So another thing we do is captive breeding for southwestern native fishes. Most of these fishes, how they breed is not known. So here's the species, here's the student, and here's what they did, and it's endangered or threatened. And they've been very successful with breeding these. Okay, there they all are. But I want to tell you about a special one, okay? You may have heard about this one on the news. If you're driving over to Death Valley and you go through Pahrump, Nevada, going over to the state line, you'll see this. And it's a sign for that, for a wildlife refuge. And you get closer to get on the wildlife refuge, there's this mountain. You drive towards the mountain, you're getting closer, you're getting closer, you're getting closer, and then all of a sudden you see this hole. And here's a hole that goes into a cavern. And you look down in that hole, and that's what you see, you know? Well, that has the devil's hole pupfish in it. Devil's hole pupfish is a 22 millimeter fish, and that was one of the fish that were instrumental in the Endangered Species Act. Harry Truman But this place was so special, it was off Death Valley National Monument. He made it as part of the monument. So Harry Truman, you wouldn't figure that guy's a desert fish conservation guy, but he went for it, okay? Here's what Devil's Hole looks like. Nobody knows where the bottom is. They've never found the bottom because it kind of goes back and forth. And they've actually had divers down there. They've had a couple have gone in and haven't come out. You know, so this was back in the 60s and stuff. So, but as far as the pupfish is concerned, the action happens on that shelf. That's where the pupfish spawn. That's where they feed. And they were pumping water out of the aquifer nearby to grow alfalfa back in the early 70s and late 60s. That was causing the water level to go beneath that shelf. And they knew if it went beneath that shelf, then the pupfish would probably die. And so they took that case all the way to the US Supreme Court on protecting these fish. And basically what it was what you do off the national monument can affect, you know, the protection of or some species on the national monument. So they shut down the alfalfa operations. So here are a couple of my students and staff. They are working in an area over there, and they studied the Devil's Hole pupfish was incredibly hard to figure out how to breed. And they asked us to try to breed these things in captivity because the number of fish in existence in the hole, live fish, got down to 35. And so there was just a few hanging on. So they said, well, let's try to get kind of a lifeboat of fish, you know, off to the side. And so that's what these scientists did. You see all their publications right there. And they went through and did that. And right now, the population's on the rise. And they've got about as many, they've got about 200 in their place. And they got about 200 in the hole. And so things are building back up right now. But it's amazing how many people are interested in this little guy. Then finally, let's talk about climate change. Okay, so I'm going to talk about the effects on fish. Climate change, billions of tons of CO2 have been pumped in the atmosphere since the Industrial Revolution, right? And so there's just a straight line correlation between carbon monoxide, methane, nitrous oxide, and the temperature going up. And they've looked at a variety of other factors. That's the one, okay? And when you look over a longer time period, even back, you know, 11,000 years, you'll see gradual changes in the climate, but you'll not see anything that's we're seeing right now, these big, fast changes. So it's human emissions of greenhouse gases. That's what it is. And so how does it work? CO2 and the other greenhouse gases has certain properties that allows them to absorb and reemit infrared light that other molecules might not have. And so that allows them to trap that heat that's here. So the more CO2 molecules you have up here, the more heat that gets trapped. It's basic physics and chemistry. Okay, and this has been known for a long time. The 1840s, 1850s, they were doing studies on this. Look at that, coal consumption affecting climate, that's 1912. You know, so this stuff's been known. I mean, it's not a new thing. Okay, these are all these separate studies and the amount of climate scientists who agree that human-caused climate change is occurring. Now, that's not that many. These are all studies of people who agree, or I think maybe a couple of them might be agreement in the literature. So this is when I sat down with some of the climatologists, this is what really hit me. I always figured, well, it's kind of like littering. If you want a litter law, you just clean it up, right? If it gets too bad. Problem is we can't go back. We keep going and going. We are stuck at whatever level we stop at. And the reason is the warming occurs in the ocean, and the ocean can let that heat out for a long time, eventually releases it. And so you can kind of see that. So if we quit, that ocean's still releasing stuff. And in fact, all the CO2, it bonds with the water, forms a weak acid. And so that acid is making it tough, you know, for shellfish, for coral, all that kind of thing. So what effects does it have on fish? Well, there's water temperature, of course. Fish are what we used to call cold-blooded. Now it's ectotherm. And all of them have different temperature curves. You start out and their metabolic activity goes faster, 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 faster. They get to an optimum and then boom, that activity goes off the charts because they can't live in that water. It's too hot. Okay. And so we tested all of our fish down here in Arizona to see. This is work that Corey Carveth did. And the surprising finding of this is our desert fish, except for things like the pupfish, the Gila top minnow, they're right in line with a lot of these introduced exotics from the east. Okay. And we were wondering, why is that? Well, back in the day, they used to have big riparian canopies, shaded things and stuff like that. So, that might be it. But a lot of the desert fishes aren't as tough as we once thought when it comes to temperature. There are some that are just very tough, but some of them aren't. And of course, the little water we have left fragments more when there's more evaporation. So what can we do? Well, first, maintain healthy riparian areas. Keep that shade on, okay? And adding shade to cool streams where needed. This is Joy Price Baker, who's doing some work, one of my students, on shading. And she actually figured out how much shade these trees provided. She used models to try to figure out how many trees would you need to plant along a section of stream to cool it off a certain amount, okay? And so shading was a big deal. We need to protect stream flow. That's quartz. And the big thing is fighting public apathy. My guess is a lot of you may not have been too familiar with desert fishes before. And I don't care what that is. You may have an interest. Oh, I like the desert birds, or I like the desert, plants. There's a lot of people out there really don't care. And so making this important for them is a critical step for all of us. I teach a communications class at the University of Arizona. I wrote a book on how natural resource professionals can work with people. And it was based on watching successful people in agencies, reading a lot of the literature, my own experiences, and then looking through politics and stuff and see what things got things done and what things didn't. And so that's all here. And then reading also what are some of the latest in social psychology. People use advertisers and what have you. Okay, so what I did on the climate change thing is I was president of the American Fisheries Society, and I went over and I talked to, you get to go around and talk to different societies, and I was talking to the Australian Society for Fish Biologists. These folks were very upset. They're dealing with the coral reefs. I talked to them and they said, I said, I heard you're losing 50% of your saltwater corals here. And they said, why don't you try more like 90% in some areas? So it was big. And they are having corals that are growing back, but they're a lot of like the weedy ones, not some of the main species. And so we talked to other fishery scientists across the globe. The oysters are not making shells. We're seeing larger, more intense wildfires here in the West. These are just some of the fires our students have worked with on fish populations. People are talking about marine organisms moving north or shifting into deeper waters. They're catching tropical fish off the coast of Maine. Midwest, there it's floods, tornadoes, all that kind of stuff, right? And then of course the reefs. The reefs are being destroyed by this. And so the fish and the aquatic ecosystems are being devastated by climate change. And so we worked with all these agencies because the most important thing you can do, not agencies, but scientific societies, is to fight climate change, is to talk about it. I mean, how many of us have a talk around the dinner table with our uncle or our friend that doesn't want to have anything to do with climate change? How many of us really talk about that? And so this is one of the climatologists saying she's found that this is one of the most important things that you can do, Catherine Hayhoe. So at AFS, we had a climate ambassadors program, which is to teach people how to use communication techniques to deal with people who are hostile. And then I contacted, and our team contacted 111 aquatic scientific societies around the world. Might be the Bulgaria, might be the Ukraine, India, what have you, and said, what are you guys seeing in climate change right now? and let's compile that with the literature. And so we put together a statement that says, here's what people are seeing, scientists all around the world. And it's signed by over 111 societies. It represents over 80,000 scientists from all 7 continents. And there you can see it if you type in that address. I'll have that again. And we said, if the goal is to preserve aquatic ecosystems, you decide if that's the goal. But you need to control greenhouse gas emissions, protect and enhance carbon sequestration, and unfortunately, we have to adapt to those changes already baked into the system. So that's the website if you're interested. And the statement did reach people around the world. It was published in Nature and many of the other journals, newspapers, what have you. And people from each society sent it to their governments. Okay. And we did here too. So those are some of the things that we're doing at the University of Arizona and with the American Fisheries Society on desert fishes. And so enjoy them. They are there, and put on a mask and snorkel next time you're at Sabino Canyon. And there's some of the out-of-towners that we can enjoy too. You know, some of these non-native fishes. They're here pretty much to stay. So might as well take advantage of those too. So thank you very much. I appreciate your attention, and it's really nice to come and talk with you tonight.
That's pretty amazing.
Yeah, it's got a lot. I get to work with some great people, so it's always fun. You get a really motivated students and staff. They take off.
So the way to find that a science statement would be like looking at the American fisheries, and what would be a key word or something?
Policy.
Okay.
Go in an American Fisheries Society, then policy.
Did you say the first one?
Yes, yeah, you could go hunt it on Nature. Something like over 100 science societies or aquatic science societies sound the alarm. So it was on Nature, and a couple of the, it was in the Phoenix paper. So it's been in a few. So yeah, you just type that in.
What
If you're
about,
having questions, can you repeat them, because the people online won't be able to hear.
Yeah.
what's out here.
Okay.
so what about sharing something like that article with our state legislature in Arizona?
We have shared it around. We could share it with other people, or we could give it to you if you wanted to share it. You know, I'm trying to remember if we actually sent it to them. We may have. I can't remember. It was about 3 years ago.
Well, probably it's that long ago, we might not remember it.
Yeah.
But Jana leads the charge on our environment day
Mhm.
in January. Isn't January?
Environmental Day at the Capitol.
Oh, okay. Okay. Well, very good. We'll make sure that if you folks want that, we can get you a copy of it, and you'll have that extra little bit.
So if you want to reach out at Environmental Day at the Capitol, you contact Sandy Barr and Sierra Club.
Oh, okay. Okay. Oh, yeah. Yeah. Sandy called me about speaking
Oh,
in the fall. So yeah. Yeah. She was doing some really good work. It looks like an energetic bunch.
Very much so.
Yeah.
Scott, we've had one question from online. Actually, there's a couple. So first one is, have you been following the treated effluent flows being introduced to the Santa Cruz River and the effect on endangered fish there and other species?
I have not. Michael Bogan is a professor at the University of Arizona, and he does a lot of work on the Santa Cruz, and he is most familiar with a lot of that. So he'd be the person I'd talk to if you're interested in that kind of stuff. And he could, if he didn't have the answer, he could point you to the right folks.
And I know the Snorn Institute has also been doing.
Yes, Snore. Yeah, exactly. Yeah, exactly. Claire over there and everybody there, they do great work, and they would have a lot of good information.
The other one was, and this may be kind of a difficult question for you to ask if you don't know the details, but why didn't Game and Fish put native fish into Peña Blanca after they cleaned out the non-natives?
Well, there's two things that affect the native and non-native stocking. And I don't know what the particular reason it is, but I can guess. Water bodies down here, there really was about 2 or 3 lakes before people came out. You know, I think Stoneman, was it Stoneman Lake was one of them, and then there was a Mormon Lake up on the rim. Okay. Other than that, a lot of our native fishes evolved in stream systems or spring systems, you know, like the little pupfish and stuff like that. And they do introduce pupfish and top minnow in a lot of those systems. So my guess is on Pina Blanca Lake, the habitat's just perfect for a pond fish. That's like a largemouth bass or a you know, bluegill. And sport fishing is an important thing for the state. So I would imagine that were some of the things that affected their decision on that. Now, do they stock a native species? Yes, of course. They have programs going on where it's appropriate with pupfish, top minnow in the springs, and they work with various groups like that. And then they also do stockings in the streams for some of the fish that are appropriate for the streams. So they have both going on. And that particular one, I don't know the specific reason, but I could have guessed it's probably something like that.
Sounds good. Any other questions anyone has?
You said something about the non-native fish, 63% responsible for 63% of something, but what are they responsible for?
I think it was of the fish that have, it's one of 2 things. On the endangered species list, they've been put into an endangered species list, was one was 48, and that might have been that one. It may have been of the extinctions that happened, 60% of those extinctions were due to interactions with non-native fishes.
That's what my pencil wanted to write down, but I just wanted to be sure.
Yeah, well, I can check it out here if you like. You guys want to see this? I don't know how much time you got. This is like about a 3-minute that shows all the desert fish species underwater, a lot of them.
Well, sure.
So, okay. How about if I get to your question? I got this right on the thing, and maybe I'll do that if that's okay.
Repeat it for the audience, not knowing.
They can hear it.
Well, they can hear it. Okay.
Okay, should I turn up the mic here? Because I don't know. Whoop.
Somehow you got on screen to.
I'm hearing the mic. I don't know if you have your computer sound might be the issue.
Yeah, I think the computer sound. So anyway, we'll do this. You can watch it without the music. I don't think that's going to matter too much.
Scott, do you know the little, when you're sharing a video and you want the sound, when you do, before you click on yes, share this one, there's a little box at the bottom left of share sound.
Oh,
And that's how that gets across to the rest of us.
Where is that image?
this is a canyon over in Nevada, Condor Canyon. And so they have these suckers that are found nowhere else except in that canyon. So that's some underwater shots of those. They have some spine dace that are endangered in some of the marshes over there. This was a place in Arizona that you can go up, and there's places you can see Apache trout and Gila trout. Now this was blown out by a fire and a big landslide, but they've restocked it. This is awesome. This is over in Death Valley. See these fish right here? They're called a cotton ball marsh pupfish. They live in water that's over 100 degrees and 5 times salinity of seawater. And so this is what some of those springs look like. That's almost like diving in the tropics. That is a Mormon springfish. There's a Amargosa pupfish, I believe.
Blue as it looks?
Oh yeah, yeah, they're just beautiful, you know. And there's some spring fishes, and that's what you have to hike out to. That's what it. So you're out in this desert, and then all of a sudden you have this wonderful little ecosystem there, and yeah. So
Where's the water for that? Is it underground from a mountain nearby?
yeah, that's right. It's like from an aquifer. The cotton ball marsh pupfish is a really tough one to get out to because it's out in Death Valley. And so they only let you in there. They say they recommend you in there no time after April because you can't carry enough water to get out there as far as how hot you're going to be. And so we packed lots of water and we're hiking and it's about 9 miles or more to get out there to the area. So you're hiking and hiking. It's hot as heck, all, Death Valley and everything. And we got out there and we couldn't find it. We looked all around. We were looking and looking. I go, oh, we can't go back. Can't find this thing. But after about an hour of looking, we found this little salt flat and they had this stream going through it. And there they were. And so we saw them. We filmed them underwater, put some cameras down there. And then we camped out on the flat at night. And what I was so surprised about was the temperature change between night and day and the amount of wind. It's almost like a hurricane. You're sitting out there and it's just blowing like crazy. Your tent is down and it's all these thermals, I think, going around. So it was a neat area. It'd be fun to go out there again sometime. Okay, so let's see. Let's see where you're.
While you're finding that slide, to answer Stuart's question, Robin Mutzer, who is part of Sustainable Tucson's Habitat Restoration Committee, she just wanted to thank you for everything you did and asked if you knew that BEAR, chose to cut down the forest at the riparian area above the dam in Sabino, which I hadn't heard about, but she was just wondering if you knew anything about that or any impacts that had, and then also really appreciated all you're doing and mentioned that she's a writer and loves to write about these topics.
Oh, well, that's great. That's great. Yeah, thank you. Sabino Canyon, we were involved in there because of the big fires they had. So I don't know what, got cleared there because of fires or what have you. So I'm not familiar with that. I couldn't really speak to that, but we did help hold some fish because when they get the big fires and then they have a flood, then you can get a blowout of your fish and they can get killed. So you hold them off to the side, you wait for all that in the watershed to grow up a little bit, and then you re-release the fish. So they've done that a couple of times in Sabino Canyon, and we've helped on that. Okay, so here we go. There's that.
Where do you report them?
We have a place at the university that's we've got tanks out the university, and the Desert Museum will hold some, and State Fish and Wildlife will hold some. So they've got a variety of people who will do that.
It's not like the county emergency operations. There are all these agencies that know each other.
Yeah, that's pretty much what it was. When they said up here on the Bighorn fire, I got a call from the Forest Service, and they said, "Can you guys hold some fish? Because that fires are going down towards Sabino Canyon." And so it's like a Saturday morning, and you just go, "Oh, that's happening again." So we had to scramble, and we were able to do that with a lot of other agencies. But yeah, you're right. It's a multi-agency effort, and you get to know the different people in the different agencies and whatnot. There's your. Oh, I'm sorry, didn't show up. What's that?
Oh, yeah, it may come loose.
No worries. Non-native cited in greater than 63% of cases of native fish extinctions. Non-native cited 49% of endangered species act listings. Good.
Then you want to make an announcement about the meeting in September?
Oh, there's no question.
This is peripheral, but where was the Cherry Creek that you mentioned 2 or 3 times?
You know,
Arizona.
Yeah, it's here in Arizona. You know where the Sierra Ancha Wilderness is? It's up by Phoenix Globe area.
Oh, yeah.
Yeah, it's up in that area. Yeah, it's spectacular. It's really neat. And yeah, this creek is a beautiful little creek, and it's got a wide variety of native fishes in it.
Do you happen to know if the Arizona Trail goes by there? Maybe that's a different Cherry Creek.
No, I there was no trail to the part we went to, I remember. It was kind of a tough one to get into. I don't know if there might be a segment that it does get to. But, yeah. Mhm.
Oh, I think we are all overawed by this topic and what you shared with us. And you have successfully pointed out that there are fish here
Yeah,
and they're part of the ecosystem. And you mentioned that just like a rivet on the airplane, losing a species could be really high risk for the ecology that we have.
Mhm. yeah, right. Yeah, you just don't know. Plus, these things are our heritage. I mean, maybe other people wouldn't feel this way, but I think we've got all this stuff that we protect in history about Arizona. Why not these? So.
The pictures really add a lot to those words, copious genetic treasures. And another fascinating example of that little beetle next to a coin.
Yeah,
So, but this thing, you said the letters of its genetic code would stretch how far?
I believe it was from coast to coast if they're printed in regular type. I think it's 12 point.
They used to have to use a narrow font or something.
There you go. That's right. If you wanted to get it down to a state, you'd have to really, yeah. Yeah. Well, thank you. Again, I really appreciate you all coming out and, yeah.